Today we will discuss one of the important topic in BEE subject, auto transformer. It is come under third unit, the auto transformer in which a part of the winding is common to the both primary and secondary circuit. It means we can use only single winding. Instead of using two winding, we can place only single winding. To observe this, there are two types of transformers depending upon construction. When it is voltage is stepped down from primary to secondary, here we can observe V1 voltage is greater than V2. In this diagram, we can observe V1 is less than V2. It is called step up voltage, step up transformer. If you observe this, here V1 is input voltage and V2 is V1 is input voltage, V2 is output voltage. The input current to be indicated with I1. The output current is I2. When look at this junction, the remaining current entering from the B point is I2 minus I1. Similar like in this, the entering current we are assuming I1 and the leaving current in the secondary it is I2. In between there is a difference between the current I1 minus I2. These are basic circuit diagrams for step-up transformer and step-down transformer. Now coming to the transformation ratio of auto transformer, generally like in case of two winding also we have K value is equal to V2 by V1 and we know it is inverse of I1 by I2. Simply we can write N2 by N1. Now if I observe this, how to connect two winding transformer into single winding, that is we can observe here. If I take it is a primary winding and it is a secondary winding, if I common these two at the point C and if I take A is the primary side and the B is the secondary side, B and C are output sides. Observe this B and C are output side and A and B are input side. Same like this. Observe this. A and B are input sides. The two windings will come here for the input side. Primary, and only CB. Observe this. CB will come to the output side, and we have to give it a V1 primary and V2 is secondary. The current is input is I1, it is I2. If I consider primary winding terms is N1, secondary winding terms are N2. Here in between these two A and C, that value is equal to N1 minus N2. N1 is a total winding and N2 is a secondary winding. This is a diagram for step down auto transformer by using two winding transformer. Now in case of this equivalent circuit diagram, we can write K is equal simply V2 V1 by N2 N1. Previous only we discussed transformation ratio in case of auto transformer. K is equal to V2 by V1 is equal to N1 by N2 by N1 and I1 by I2. Now there are mainly three types of application in case of auto transformer. First one is power transfer. In auto transformer there are two types of power is transfer. One is inductively, another one is conductively. If I consider to inductively, the output voltage is V2 and the difference in case of currents is I2 minus I1. You can observe in the circuit diagram, if I multiply this V2 I2 and we know K is equal I1 by I2, then the inductively power transfer value is equal input into 1 minus K. We know after getting inductively power transfer 1 minus K, the remaining is power is transferred by using conductively, that is equal to input minus input into 1 minus K. That is simply we can write K into input power. Let us take one example. The transformer rating is 500 watts. The voltage transformation ratio K is equal to 1 by 4. Then the power transfer by inductive is equal to input into 1 minus K. That value is equal to 500 into 1 minus K. The K value they give us 1 by 4, that is 375. And K is equal to input, that value is 1 by 4 into 500 is equal to 125. Now if you add these two, you will get 500 watts. The 375 is inductively transferred power and the remaining is conductively transferred power. I hope you all of you understand how power is transferred in auto transformer. There are two modes. One is inductively, another one is conductively. Next, coming to power, coming to the copper saving in auto transformer. Instead of using two winding transformer, if I go for auto transformer, we can save the amount of copper, that is equal to nearly k times of weight of weight of copper of two winding transformer. Now we will derive that equation by using simple methods. First one is we have to take weight of the copper required in case of a two winding transformer, that is I1N1 plus I2N2. If you observe in the diagram, it is I1 current will flow and number of turns is N1, and in case of secondary winding it is N2 and the entering and the leaving current is I2. It is total copper required in case of two winding transformer, but in case of auto transformer we can weight of the copper is in section A to C. Now only we saw it is A, C, B. In case of auto transformer up to A to C, the weight of the copper is equal to I1 into N1 minus N2. In case of CB section, I2 minus I1 is equal to N2. The total weight of copper is equal to I1 N1 minus N2 plus I2 minus I1 into N. Now to get the ratio of these two weights of copper in auto transformer and weight of copper in two winding transformer, finally you will get 1 minus K, that is equal to 1 minus K. It is the weight of copper in auto transformer is equal to 1 minus K into weight of copper in two winding transformer. The remaining is equal to, that is nothing but saving of copper is equal to K into weight of copper in two winding transformer. For example, thus K is equal to 0.1, the saving of copper is only 10%. If K is equal to 0.9, the saving of copper is 94. Therefore, the nearer the value of K auto transformer is to 1, the greater is the saving of copper. It is very important. We have to take the K value near to 1.